Over the past few months, we've been transforming my wrecked Porsche Boxster into a GT3 RS, and this thing is starting to look real. We've finished the front.
Oh, it's like sharp.
Finished the rear, fabricated mounts for our rear bumper, fabricated mounts for our front bumper, temporarily mounted our fenders and our quarter panels, and we even got our hands on genuine GT3 RS taillights. Let's go see what the boss thinks.
This is gonna work great. It's really nice. It's good looking.
But not everything has gone smoothly. As you can see, we've been fighting some pretty frustrating warping and fitment issues that could completely ruin the bodywork if we don't fix them. But we're not stopping now. This car is getting closer and closer to my 16-year-old dream build. And today, not only are we gonna fix those issues, we're finally gonna be mounting our fully custom designed roof that we have spent the past week designing in Autodesk Alias that will blow you away. And trust me, once this roof goes on, this thing starts looking like a real GT3 RS. So without further ado, let's begin. To kick things off, we need to get this car scanned. That means covering the entire body with tracking markers so the scanner can accurately map every curve and panel. Now, most people use dedicated scanning dots for this, but we're taking a much cheaper approach and using blue masking tape instead. It's a fraction of the price, and it works surprisingly well, and as long as we place everything evenly, the scanner has no problem tracking the car. But to make sure we get the most accurate scan possible, we're also dusting the car with a mixture of baby powder and water. This gives the surface a uniform matte finish, which makes it easier for the scanner to pick up all the details without getting confused by the reflections. And once that's done, we can finally start scanning the car. Now, if you've never seen a 3D scanner before, it's honestly pretty incredible. As you move it around an object, it's constantly capturing millions of data points and stitching them together to create an incredibly accurate digital model. The crazy part is that this level of technology used to be reserved for massive manufacturers and engineering companies. And even today, these scanners aren't exactly cheap. So the fact that we're using one to design a custom GT3 RS roof inside our tiny 2-car garage is honestly kind of crazy. But if we want this roof to fit like it came from the factory, this is the best way to do it. The main areas we're focused on are the factory seals where the soft top meets with the windshield and the A-pillars. Capturing these sections accurately is incredibly important because they'll help us determine the exact shape, fitment, and curvature of our custom roof design.
Just wanted to get that flange. Let's see what's going on.
We also went ahead and scanned portions of the mirrors, doors, and window openings. Those areas will give us even more reference points to work from and help us ensure everything flows naturally with the rest of the car. As for the windows, we'll eventually be making those out of Lexan, but that's a project for another video. And just to make sure we captured as much useful data as possible, we also scanned the hood and one of our front fenders. We may not need those scans right away, but having them gives us additional reference geometry to work with later in the build. When you're designing a completely custom roof from scratch, you can never have too much information. All right, after gathering all the data we needed, we exported the scans and brought everything into Autodesk Alias. From there, my brother Adam got to work. Over the next 4 days, he transformed millions of scan points into a fully custom roof design, built specifically for this Boxster. And honestly, watching this thing come together on the computer was pretty incredible. With the design finally finished, all that was left to do was start bringing it into the real world. But of course, nothing's ever that simple. Just as we were getting ready to start printing roof sections, the main 3D printer we planned to use completely stopped working. After a bit of troubleshooting, we discovered the extruder gear had essentially shredded itself.
See, it's broken right there.
Needless to say, that wasn't exactly the timing we were hoping for. We've already ordered upgraded metal replacement gears, but until those arrive, that printer is officially out of commission. Luckily, we aren't completely stuck. We still have several other printers available, so while we waited for parts to arrive, we got straight to work printing the first pieces of our custom roof. But while those parts are being printed, there still was plenty of work to do on the car itself. One area that still needed attention was the underside of our hood. If you've seen in the first video in this series, you'll know that the hood has already been sanded and prepped. So now, it's finally time to lay down the first layer of carbon fiber. After positioning the hood, we cut the carbon fiber to shape and got everything ready for resin. For this layup, we're using a mixture of polymer resin and MEKP hardener, and once everything is thoroughly mixed, the clock starts ticking. Because of the size of the hood, we worked in sections, carefully wetting out the surface and making sure every area was covered. This is one of those jobs where patience is everything. Take your time now and you'll save yourself a lot of headaches later. Once the entire surface was covered, we can start wetting the carbon fiber until fully saturated through. And after all that, there was only one thing left to do. Let it cure overnight and hope everything went according to plan. The next morning, we got exactly the result we were hoping for. With the carbon fiber fully cured, we reinstalled the hood on the car and stepped back to take a look. And honestly, seeing another major piece finally come together felt pretty good. But of course, there was still a massive amount of work left before this car would be ready for its custom roof. The next job on the list was sanding. And not just one or two panels, we're talking about the whole car. So the hood, the front bumper, the rear bumper, the duckbill, both quarter panels, and both fenders. I knew going into it, this wasn't going to be a quick job. In fact, I was pretty sure I'd be working well into the night. Now, we're not sanding these panels just to make them look nice. Most of these parts are still raw plastic, and before we can start applying any body filler, we need to give the surface enough texture for everything to properly bond. If we skip this step, there's a much higher chance of issues showing up later down the road. So with that in mind, it was time to get to work. I started by cleaning up the edges of the hood after the carbon fiber layup before moving on to the rest of the body panels. Or at least that was the plan.
Yeah, we gotta fix it.
Almost immediately, we ran into another issue with the hood. We got our safety glasses on, and we're soldering the hood because it's completely broken here. While we were working on it, the hood ended up cracking along one of the seams, forcing us to stop and repair it before we could continue. The fix itself wasn't too complicated. We decided to plastic weld the seam back together, and everything was structurally sound again. Of course, things got a little more interesting while we were doing it.
It smells like steak.
Apparently, we were so focused on the repair that we didn't even notice the soldering iron slowly melting straight through the cable.
Yeah, we're just gonna unplug that soldering iron so it doesn't melt everything.
And after a little bit of laughing and a slightly damaged extension cord later, we were finally able to finish repairing the hood.
We did it! Congratulations!
Yay! At the time, we thought it was just a minor setback, but little did we know, this hood was about to become one of the biggest headaches of the entire build. But more on that later. With the repair finished, it was finally time to get back to sanding. I started with the duckbill before moving on to the front of the car. From there, it was one panel after another. The hood, passenger side fender, driver's side fender, and finally, the front bumper. By this point, hours had gone by, but the front end was finally starting to look properly prepped for bodywork. And before calling it a night, there was one more thing I wanted to get done. I went back through the entire front end and reinforced all the panel seams with super glue. The goal here was simple. Make sure everything stayed as strong and as stable as possible before we started applying body filler. And yes, I may have gone through an absurd amount of super glue in the process. I wanted to show y'all what glue we're using. We bought this big pack of these little bottles of super glue. It's just some random brand, but it does work really good. You can get this for like $11 and it's really good. For some reason, it's better to buy like a gazillion little ones instead of one big bottle, so that's what we're running. As I finished up the last few seams, I couldn't help but step back and look at how far this project has come. What started as a wrecked Boxster is slowly beginning to resemble the car I've always dreamed of building. And honestly, being able to share that journey with all of you has made this project even more rewarding. We still have got a long way to go, and trust me, some of the most exciting parts of this build are still ahead of us. But seeing this front end finally sanded, reinforced, and ready for bodywork felt like a huge step in the right direction. With the front of the car finished for the night, it was time to move on to the rear and keep the momentum going. I started on the driver's side quarter panel, but it didn't take long to realize we had another problem. The air compressor we were using just couldn't keep up with the orbital sander. It worked fine for short bursts, but once we started covering larger areas, it became painfully obvious that it wasn't going to get the job done. So rather than calling it a night, we decided to get a little creative. After looking around the garage, we found a tool that looks like it might work for our sanding discs. With a little bit of trimming and modification, we ended up creating what can only be described as a highly professional, state-of-the-art sanding device. Or at least that's what we were calling it. Honestly, I wasn't expecting much, but as soon as we tested it on the passenger side quarter panel, it completely exceeded my expectations. It was faster, easier to control, and didn't rely on an air compressor at all. And after about 5 minutes of using it, I couldn't help but wonder why we hadn't made one of these sooner. Sometimes the best tools in the shop are the ones you invent. After finishing the rear quarter panels, I went back through and reinforced all the seams with super glue just like we had done on the front. While we were working back there, we also removed the factory quarter panel mounting arms. Since they won't be used with our custom setup, there was no reason to keep them around, so off they came. And just like that, a few more unnecessary pieces found their way into the scrap pile. At this point, every major body panel on the car had been sanded, prepped, and reinforced. While all that was happening, the roof printers had been hard at work in the background, and now it was finally time to see whether all those hours of scanning, designing, and printing had actually paid off. To be honest, I had no idea what to expect. This was the very first time we would be test fitting one of our roof sections on the car, and if our measurements were off, even by a small amount, we'd find out pretty quickly. So with the bodywork wrapped up for the night, we grabbed the first roof piece and headed over to the car.
All the panels are now sanded on the car and glued, so they should be extra strong. But now we have to test fit our first piece to the roof.
Just moving across this car is crazy. I mean, just look at these panels. They're so smooth. And we're gonna body filler all of this, so it's just gonna be even crazier. But as you can see, the roof has this rubber flange for the soft top that was originally on it. We designed our panels so that it wedges in there with this piece. As you can see, this is the corner. So all we have to do is essentially just push this in, and it will kind of just wedge itself in there, and boom. You just gotta hold it, because we're gonna put some screws, but look at that. That gap is almost perfect. And as you can see, this kind of lines up. We're just gonna fill this gap in a little bit with body filler, but this is insane. Look at that. That's gonna look so good. With that first roof section fitting almost perfectly, we finally had the green flag to commit to assembling the entire roof. And trust me, that was much easier said than done. In total, this roof consists of 44 individual pieces. Considering a large portion of them look nearly identical, figuring out where everything went was almost like putting a giant puzzle together. And because the roof is almost completely flat, even small alignment errors could cause major problems later on. Unfortunately, we didn't film an entire assembly process between printing parts, test fitting, welding, and making adjustments. The assembly ended up taking multiple days and would have generated hours of footage. But I did manage to capture some of the process along the way. So the way we do these welds is we tack them first, and then we will later final weld it just like how we did over here. And we'll do it to this whole thing right here to make sure that it is nice and strong. And slowly but surely, the roof started becoming a real thing. After days of printing, welding, and fitting parts together, we finally reached a point where the roof was nearly complete. Okay, so the roof is almost done. I just need to do a few more final welds, and then it's literally chef's kiss, perfect. I'm excited. And that's when reality started to set in. For the first time, we were looking at an actual full-size roof sitting in front of us. The only problem, we still had to move it into the garage. And considering that this thing was made from dozens of individual printed pieces, there was only one thing on my mind. Please don't break. All right, here we go. Gonna pick it up. Hopefully, no cracking. Oh, I don't hear any cracks. Pretty solid. Sounds good. All right, let's bring it to the garage. Somehow we managed to make it into the garage without destroying it, which honestly felt like a win itself. But then I made a mistake. The second it was inside, I couldn't resist seeing what it would look like on the car. So before we had finished reinforcing everything, before we added all final structure, and before the roof was truly ready, I decided to test fit it anyways. Looking back, that probably wasn't my smartest decision. And within seconds, we learned exactly why. That was not good. That was not good. Yep, it broke. Not exactly the outcome we were hoping for. All right, well, that's not very good. Yeah, the whole thing cracked, so we're gonna have to take it back to the back, weld it back up, and then clearly this thing cannot be moved until carbon fibered. The good news was that the damage was repairable. But the bad news was that the roof was clearly not strong enough to be moved around until it had additional reinforcement. So for now, it was headed back to the back to be plastic welded back together. And while those repairs were underway, there wasn't much point in standing around feeling sorry for ourselves. There was still plenty left to do. In fact, one of the biggest jobs remaining on the car was getting the entire front end fully prepared for bodywork. Up to this point, we've spent countless hours fitting panels, adjusting gaps, sanding surfaces, and reinforcing seams. But now it's time to finally start locking everything into its final positions, because once body filler starts going on, there's no more pretending. Every panel gap, body line, and transition needs to be exactly where you want it. And if we wanted this thing to eventually look like a factory-built GT3 RS, this step was going to be incredibly important. The first area we tackled was the front fenders. Before we could even think about body filler, we needed to sort out some of the panel gaps. The biggest issue was the clearance between the hood and the fenders. Every time the hood opened, it would rub against the edges of the fenders. So we grabbed the Dremel and started carefully trimming material away until the hood could open up and close without any interference. These gaps would eventually be fine-tuned down to around 3 millimeters, but for now, our goal was simply getting everything functional. With that sorted, we moved on to another problem, a very annoying hump that had developed in the hood. There is pretty much a hump on this hood. If you can see it, it kind of shows. There's a little bit of a hump right there. So we're gonna push it down and we're gonna hold it with a brick. The plan was simple: apply heat, reshape the panel, and hopefully get it sitting where it belonged. While we're at it, we also tried addressing the gap between the hood and the front bumper. Neither had been fixed completely, but it was definitely the step in the right direction. Moving to the rear of the car, we removed the porta powder that had been holding one of the quarter panels in position while it's cooled. Okay, we are now gonna remove our porta power from here. Right now, it's just been pushing up on this for like hours straight. So let's see what happens when we remove it. I'm gonna turn the knob. There she goes. So it is definitely a little bit better, but we still need to do some pushing clearly, because that did not work enough. So we're gonna heat it up again and push it again. The panel looked better, but not perfect, so we repeated heating and reshaping process several more times. Even after all that, we knew some of these areas would need to be revisited later. And while we're talking about the quarter panels, we also decided to remove the fins. So we have both of our fins here. We took this one off first, and as you can see, it cut a little bit rough, but that is okay. The second one, this piece broke off, but this was because it was on the weld point. That's no biggie. But we're gonna remodel both of these fins, and then we're gonna bolt them back onto the car, just like how the factory
GT3 RSs do their fins.
With most of the warping issues temporarily under control, we could finally move on to something we had been putting off for a while: permanent fender mounts. Up until now, we've only been using the temporary mounting solutions. They worked well enough for mock-up purposes, but there's no way they'd survive long term. So we grabbed our old factory fenders and started marking out the sections we needed.
Okay, so after a little bit of referencing, we determined that we're gonna cut our fender along these lines right here. We've determined that we wanna cut right here along this and go along here all the way. Ignore that, that was just a mess up. And we're gonna go all along here and then up, and we're gonna include this last bolt. So there will be 6 bolts. We are not including this one because this wedges under the hood latch, so we don't want that. And we were kind of just determining whether if we should cut here or not, so that's why there's these old lines, but we are gonna be using this line all right to here. And then we're also cutting out the gas cap. We're just gonna cut it about that much, doesn't really matter. We just need the main part. And then we're also gonna be cutting our factory mount holes for the back part. And we're just gonna do that. And that should be plenty. So we're kind of cutting a little extra. We're gonna have to trim it down probably because we're cutting excess, but it's better to cut excess than it is to cut too little, so.
Before cutting anything up, I wanted to explain exactly how the new mounting system was going to work.
So for our fender, I had put a couple holes here to put some nuts and bolts for a T-bracket. As you can see, this T-bracket is holding on, or sandwiching together, I guess, our bumper and our fender. So it is pretty solid, and we have a good flush gap all along. So we're gonna also drill nuts and bolts for the little bracket that's under the fender and the bumper that meet. So this will be sandwiched perfectly. I don't know if you could see it, but I don't know if you, yeah.
Once the plan was finalized, we started cutting. One fender became 2 mounts. And before long, both sides of the car were getting upgraded. We also added riv nuts to several mounting locations because the factory attachment points simply were just not doing the job anymore. At first we thought that would be good enough, but it wasn't. The more we worked with the panels, the more obvious it became that we needed additional support. So I grabbed a large sheet of thin steel that happened to be almost the perfect thickness. After cutting a strip for each side, we started shaping them to match the curvature of the fenders.
We have our metal strip that's gonna go along our fender. Let's test fit it. It should just fit snug right in there. And of course we chose a steel so we can weld it, and also a steel that's kind of thin. We don't want too thick steel, one that can really like flex with it. And as you can see, it has that slight bend to it, and it's kind of just bending with the panel. And as for the dimensions of this piece, I cut it 2.5 inches wide and roughly 43.25 inch long, which is like 110 centimeters. I think 110 centimeters to be exact. And as for this side, I found a scrap metal strip that is 2.5 inches wide exactly, but is I think 57 centimeters long. And I cut a piece that is 53 centimeters long. So now we have 110 and 110 on both sides perfectly. We're gonna weld those two together so that we have one full strip. And then we're gonna self-tapper both sides, and it should all be solid. And then we'll adjust it to height with the hood, and then it should look perfect.
One strip came from the largest sheet, while the second was made from some leftover material we had lying around. And as an added bonus, it gave me an excuse to practice welding for the very first time.
Woo! Beautiful, look at that.
Once both reinforced strips were finished, we pre-drilled all the mounting holes. The goal was to make everything as accurate as possible, which is exactly why we broke out the drill press. After that, we brought everything over to the car and started lining up the final positions. Once the self-tappers went in, the results honestly exceeded my expectations.
So we have the driver self-tappered and it is strong. I mean, seriously, this is not moving at all, and I'm moving it with force right now.
The fenders were dramatically stronger than before and finally felt properly supported. And with the fenders sorted, it was time to give the front bumper the same treatment. So I bent up a L bracket that we use. Usually they're straight. I bent it by hand because we don't have a tube bender, but I did a pretty good job. As you can see, if I go on the car here and I line it up flush with the panel, I marked where I have to bend this flat piece, but it will be perfect. Obviously I loosened that plate so it doesn't line up as good, but it should be perfect. So I'm gonna bend this flat piece so it's flush with the bottom here, and then we'll be able to push up on our bumper so we can have these gaps here meet perfect with the hood. All that was left was putting a bend in the final brackets, so over to the vise we went, and honestly, it turned out exactly how I wanted it. It's a good reminder that you don't always need expensive equipment to make something work. So the bracket is now mounted to hold our bumper up. It's nice and tight, it's pretty sturdy, and what we're gonna do is just put a self-tapper right through this, and on the inside, it will go straight through, and it should hold this all in place. This is bent perfectly so that it's flat still for the screw, and it is perfect. With the front bumper now supported as well, there was just one last thing we needed to address, the fuel door. So we removed our gas cap cover here, and if we go over to our fender, I traced out where it's gonna go on our fender. It can't go straight, sadly, because it has to match with the curve of the fender. And basically, this is the best point of where it can go. It has a little wiggle to it, but that is probably the best point. And basically, we're just gonna cut it out and we'll slide the housing through it. We're gonna trim around the housing because we have some excess to trim off. And then it should look perfect. We removed the factory fuel door assembly, matched the curve to the new fender, and marked out exactly where everything would need to be cut. The goal is to reuse the factory fuel filler housing and make the whole thing look as close to factory as possible. But since we didn't have all the tools we needed to finish that job properly, we decided to put it on hold and come back to it later. After all that fabrication, there still was one thing bothering me. I just wasn't convinced the fenders were strong enough. So I cut out these two 10.5-inch brackets that we're gonna use to make the back part of the fenders a little stronger, because right now they're kind of just not where it needs to be, and also they're just kind of easy to push on, which is not really what we want. We want it to be one solid panel, so this should make it definitely a lot stronger. The idea was simple: spread the load across a larger area and eliminate as much flex as possible. But before we could install them permanently, the fenders had to come back off, so we pulled everything apart once again and welded the new brackets into place. With the welding finished, it was finally time to see if that extra work had been worth it. We drilled through the mounting locations, ran in a self-tapper, and effectively sandwiched the entire assembly together. And honestly, it worked out even better than I expected. The fender felt significantly more rigid, and for the first time, it actually felt like a proper structure instead of a collection of parts bolted together. At this point, the front end was finally starting to feel solid. Well, almost, because there was still one final job left before we could officially call the front end ready for bodywork. We still needed to go back and reinforce a few areas with additional superglue, make some final adjustments, but the biggest remaining task was permanently welding the front bumper mount into its final position. Once that was done, everything was finally tied together as one complete assembly. And honestly, seeing all these individual pieces slowly become an actual car has been one of the most satisfying parts of the entire build. All right, I got the bumper welded now, and now we're gonna test to see if it worked, if it is gonna stay in place. So if we just lower this jack, we should not see any movement. Yes, it stayed. Oh, that is amazing. I'm gonna pull the jack out and look at that. Right where it should be. Perfect. With the front end finally sitting where we wanted it, it was time to revisit something we'd been avoiding: the roof. After the failed test fit and a round of repairs, it had been sitting in the back of the shop waiting for us to come back to it. And now that the front of the car was essentially sorted, we could finally give it the attention it deserved. So we brought the repaired roof back into the garage and got ready for what should have been done from the very beginning, adding carbon fiber. Up until this point, the roof was still relying almost entirely on the printed structure for its strength. And as we already discovered, that wasn't exactly ideal. The goal was simple: make it stronger. The first step was cutting the carbon fiber to match the shape of the roof. But before we can start mixing resin, we ran into a problem. The rollers we used for laying out carbon fiber had become a constant headache. Once resin cured inside them, they were basically done for. And after throwing away roller after roller, we decided enough was enough.
So before we lay down our carbon fiber, I have one of our rollers here that we use, and we're just tired of having to keep reusing these rollers. So we're gonna design a 3D printed part that we can reuse for this roller so that we never have to keep buying these things again.
So instead of buying more, we made our own solution. We jumped into CAD and designed a fully reusable roller attachment that could be 3D printed whenever we needed one. A few hours later, we had our first prototype, and honestly, it worked better than we expected. From now on, if we wear one out, break one, or need another size, we can simply just print a new one. No ordering parts, no waiting for shipping, just hit print and keep building. And for a project with this many custom parts, that's a huge advantage. With that problem solved, it was finally time to start laying carbon fiber.
Now it's time for the stinky part, time to mix our solution.
Once the resin was ready, we folded one half of the carbon fiber back and started wetting out the surface underneath. After that side was coated, we carefully folded the carbon fiber back over and repeated the process on the other half. From there, it was just a matter of fully saturating the carbon fiber and working out any imperfections. And before long, the entire roof was covered.
All right, so our carbon fiber is now laid down. We're gonna let that cure and we're gonna get on to the next thing.
For the first time, this thing was starting to become the structure we originally envisioned. Now all that was left to do was wait. The next day, the roof had fully cured.
It's the next day now and our roof is fully cured and this thing looks amazing. We did a really good job. I think this is one of our best panels yet that we did.
And I have to admit, I was a little nervous walking over to it. This was easily one of the most ambitious parts we've attempted on the entire build. What started as dozens of separate printed pieces, countless hours of design work, welding, fitting, repairing, and now carbon fiber had finally become a single structure. And thankfully, the results were exactly what we hoped for. The roof felt dramatically stronger than before, which was pretty big relief, considering that the last time we tried moving it around, it literally broke. At this point, the carbon fiber had done exactly what we wanted it to do. It transformed the roof from something that felt fragile into something that actually felt structural. But before we could go in the car, there was still a little cleanup work left. The edges had excess carbon fiber that needed to be trimmed away. So I spent some time going around the entire perimeter, cleaning everything up and getting it ready for installation. And while I was trimming the roof, our mounting brackets finally finished printing, which meant we now had everything we needed to mount the roof onto the car for the very first time. Well, almost. There was still one final challenge. Before the roof could fit properly, we needed to trim the quarter panels a little more. The way this roof was designed, it simply doesn't just sit on top of the car. It actually flows directly into the quarter panels, and the mounting brackets are sandwiched between both pieces. If the quarter panels weren't trimmed correctly, nothing was going to line up the way we wanted.
Of course, it wouldn't be a custom car project without running into one more issue.
When we started test fitting the roof, the fitment wasn't quite where we wanted it. Something was preventing the roof from fully seating into position. After taking a closer look, we realized what happened. When we carbon fibered the roof, the flange where the roof slides into place became slightly thicker. Normally that wouldn't be a huge deal, but combined with the rubber seal we had originally planned on using, there simply wasn't enough room to fit everything properly together. So rather than cutting things apart, we decided to remove the rubber seal for now. The nice thing is we can always revisit that later. But for the moment, our priority was getting the roof on the car, and almost immediately the fitment improved. The roof sat further into position, the body lines flowed much better, and it gave us a much clearer picture of what still needed to be adjusted. From there, it was back to trimming, test fitting, and making sure small adjustments until everything lined up the way we wanted it. This ended up taking longer than expected. Trim a little, test fit, remove the roof, trim a little more, and repeat the process over and over again. Because once material comes off, there's no putting it back. So every cut had to be deliberate. And slowly but surely, everything started coming together. The gaps got tighter, the body lines started flowing, and for the first time, it felt like the roof and quarter panels were actually becoming one piece. Once we were finally happy with the fitment, it was time for the moment we'd been working towards this entire video, the final installation. We secured the mounting brackets, installed the self-tappers, and started locking everything into place. And just like that, the roof was finally mounted. And honestly, pictures don't really do its justice. For months, this thing has existed mostly as ideas. CAD models, printed parts, and piles of plastic scattered around the garage. But now it actually looks like a car. The roof completely changes the proportions, it changes the silhouette, it changes the entire personality of the build. And standing back and looking at it for the first time was one of those moments that makes all the frustration feel worth it. The failed prints, the warping, the repairs, the roof breaking, all of it. Because for the first time, I could actually see the vision of it coming together. And the craziest part is we're just getting started, because in the next video, we're finally moving into bodywork. In fact, I was so excited to get to that stage that we already started putting body filler on the ducktail. But that's where we're going to leave things for now. If you enjoyed the video, make sure you leave a like, subscribe if you're new, and I'll see you in the next one. Thanks for watching.